All right, we are going to now talk about factoring polynomials or unfoiling them. Everything else we're going to do this quarter is all about factoring. So those of you guys who've already done this in Algebra 1 and you caught on to it, hooray, this will be the easy part. I'm going to show you a couple tricks that you may or may not have understood before when you do these. So we're going to start with what I call the easy ones. They're in the form ax squared plus bx plus c, where a is 1, meaning there's nothing attached to this x. So some of you guys learned right away that when you factor something like this, you just throw an x in the parentheses. That works, or b or a or g or whatever. I don't care if you want to do that, that's fine. What I'm going to focus on is like the steps that I follow to factor something, because in my mind, the variable or whatever goes in front is what comes last in this case. So first let's go back and talk about where this comes from. This is a factored polynomial. What we did before was to FOIL this thing. So if I FOIL it or distribute it, I get x times x, which is x squared. I get x times 2. I get negative 3 times x. And I get negative 3 times 2. Combining my like terms in the middle, I get, for the purpose of this, 1x, negative 1x, sorry, and then plus 6. So I'm going to take this polynomial and factor it in this form. So this is what you do. This part right here is a product. And that product needs to be factored, meaning divided. So you have to think about what times what is 6. So pretend like we don't know that 2 times 3 is 6, but that's usually the ones that you think about. But there's also 1 and 6 that work. In the middle, this is a sum. And what I call this is the say it, which is going to make sense in a minute. So what I'm going to do is I'm going to think of what numbers multiply to give me 6, and I'm going to put them together in some way, sum, and as I say it, it's how it's going to fit in the parentheses. So when I sum, it's not really a sum, it could be a difference. I'm either going to add or subtract here. Because it's going to make a difference how it comes out in the end. All right, so I'm going to start with this. I'm going to factor 6 to be 2 and 3, because that's usually the one we think of. And then I'm going to say this in my head, 3 plus 2 is negative 1. No way. 2 plus 3 is negative 1. No way. So it's not a sum, it's got to be a difference or a subtraction. So how this works is, now I got to figure out how to get a negative 1. Most of you guys probably figured this out, how that works, but I'm going to do it this way. 2 minus 3 is a negative 1. Excellent, that's right. So I'm going to write it in my parentheses exactly the way I say it, 2 minus 3, and now I can put my x's in here, and this was a positive 2. So 2 minus 3 gave me that negative 1. Ta-da, that's it. I know that's a long explanation of how you do this. All right, so the next one, I'm going to look at 28. So what times what is 28? Well, the first thing I can think of is 4 and 7, and maybe 2 and 14. So I'm going to start with 4 and 7. The obvious ones are not always the ones that worked. I just happen to choose some examples that this is how this goes. So then now that I've done this, I have to figure out the 11. So 4 plus 7 is 11. Ah, yay, it is. So 4, positive 4, plus 7 is 11. B goes in front, B goes in front. If you would have said it's 7 plus 4, these would just be switched around, and it doesn't really matter how you do that. Most beautiful books tell you to get the smaller factor first and then the larger one. It doesn't really matter how you want to do that. All right, sometimes you have polynomials that have a variable on both ends, so there's a double variable in the middle. All you have to do with this variable at the end is you're going to put it in the end of your parenthesis because it's squared. Now there are cases when you factor this that these could be any power, any multiple of 2, 2, 4, 8, 16, whatever. We'll get into those later on and you'll see those in your homework assignment. All right, so anyway, 48. 48 is 6 times 8, 2 times 24, 3 times 16, that should be enough because I can already tell how this is going to work. Hopefully you caught that as well. So this time I'm going to say 6 plus 8 is 14. It's true, except for it's negative. So that negative means that both these have to be negative numbers because in order to add them together to get 14 and get a negative 14, they both have to be negative. So again, it doesn't matter how I do that. Negative 6 and negative 8 go in there. I'm going to put the h on both of those because that's where that h squared comes from. And the g in the front. Ta-da! Done. All right, one more just because. Trying to make something else work. So 10 is 2 and 5. Or 1 and 10. I tried to find one that used a 1 and whatever factor, but not in the examples that I found. So anyway, we'll do it this way. So 2 plus 5 is 3. Nope. 5 plus 2 is definitely not 3. And again, I'm just going back and forth between them because sometimes you don't catch yourself when you say it the first time. So now we got to go the other way. 2 minus 5 is a 3. No, but 5 minus 2 is 3. So 5 minus 2 is 3. So that means that's a plus. And I put my C in front. And ta-da, there you go, I've factored these.